The Moon is the Earth's closest space neighbor and its only natural satellite. It likely formed when a huge Mars-sized object crashed into our planet billions of years ago. I wasn't around then. This catastrophe turned Earth into a scorching ball of molten rock. It also pushed some material into its orbit, creating the Moon. Now, this heavily cratered sphere moves around our planet. This causes high and low tides around the globe. A bit more than 1/4 the size of Earth, it's the 5th largest natural satellite in the solar system. The Moon has several phases. For example, new, full, or crescent moon, first and last quarter. But whatever the satellite looks like, you can always find it in the night sky, and sometimes even during the day. But imagine waking up at night and noticing that the Moon looks somewhat different than usual. It seems brighter and bigger. It's hardly noticeable, especially when you're half asleep. You go back to bed, unaware that instead of the Moon, you've just seen Mercury. Close up, this planet, the nearest to the Sun, is similar to our natural satellite. Its surface is littered with craters left by space rocks. Mercury is about 2/5 the size of our planet, but it's still a bit larger than the Moon. That's why the planet would have a greater influence on Earth. Nights would become brighter, high tides would become higher, and low tides, what do you think, lower? Yup. The lunar cycle, that's the time the Moon, or rather Mercury now, needs to go through all the phases, would become 14 hours shorter. But all in all, such a replacement wouldn't have any drastic consequences for our planet. But then, how about Venus? What if, instead of the familiar satellite, we swap in the third brightest natural object after the Sun and the Moon? It's often called Earth's sister planet because their mass and size are nearly the same. Venus would be as large in our sky as Earth once appeared to the Apollo astronauts when they looked at it from the Moon's surface. The morning star would be much brighter than the Moon. For one thing, the planet reflects 6 times more sunlight. Plus, it would occupy an area at least 16 times larger. That's why nights on Earth would be as bright as early twilight now. If you looked at Venus, you'd spot vague swirling patterns in the planet's yellowish-white cloud cover. Venus wouldn't become Earth's satellite. The two planets would likely orbit around their common center of mass, and this orbit would be quite eccentric, like me. But if Venus moved with the same speed as the Moon has now, the two planets would crash into each other in the nearest future. Uh-oh. Okay, let's pull another switcheroo. If Mars was up there in the sky instead of the Moon, you'd surely notice it. The planet's disk would look reddish. Make that reddish. And it would be almost twice the Moon's size. Even without a telescope, you'd be able to marvel at its unusual color and dark spots on its surface. And even if you didn't see the red planet, you'd still feel something unusual. Mars is half of Earth's size, but several times larger than the Moon. Replacing a smaller space body with a much bigger one would upset the delicate balance on our planet. If you were unlucky to be at the seaside when Mars took the Moon's place, you'd have to evacuate as soon as possible. Massive waves would rise in the oceans under Martian influence. They would crash against the shoreline like the largest tsunamis. Mars would be reflecting more sunlight than the Moon. Nights would be lighter. Terrestrial landscapes would have an eerie red tint. And you'd be able to admire the tallest mountain in the solar system, Olympus Mons, through a telescope. Mars isn't large enough to change the Earth's orbit dramatically, but with time, the two planets would probably begin to orbit each other, creating a binary planet system. And since Mars would literally be next door, voyages to this planet would become a reality. Okay, now think really big. If Jupiter replaced the Moon, Earth, as an independent planet, wouldn't exist anymore. It would instantly turn into another moon of the largest planet in the solar system. The only positive moment in this transformation? People would have an awesome sky view. Jupiter is dozens of times larger than the Moon. A gigantic, beautifully striped sphere would cover nearly all the horizon. If you had time to enjoy the show, you'd see yellow, brown, red, and white clouds floating in Jupiter's atmosphere. Sadly, the gas giant's gravitational pull would instantly cause severe earthquakes, volcanic eruptions, and tsunamis. Earth's mantle and crust would be drawn toward Jupiter, which would break the planet apart. It'd be stretched and compressed with such force that its surface would bulge back and forth by more than 300 feet. Unfortunately, Earth's speed is only 10% of the speed needed for us to stay in Jupiter's orbit. That's why our sluggish planet would crash into the gas giant in less than a day. Well, that sounds unpleasant, so let's not do that. Now, if Saturn were to replace the Moon, it would be a sight to behold. The planet is more than 35 times larger than our satellite. It means the giant golden globe would cover 18 degrees of the sky, and its rings would stretch even further, from horizon to horizon. Hey, if you like it, then you should have put a ring on it. Earth would be a bit further away from the gas giant than its own moon, Dione. And since Saturn is way more powerful than our planet, Earth would turn into its satellite, not the other way around. Unfortunately, Earth's rotational speed wouldn't be enough to keep up, and we'd most likely crash into the much larger planet within a day or two. But before burning up in Saturn's atmosphere, we'd have to pass through its magnificent rings. They're made up of pieces of comets, asteroids, and shattered moons. It wouldn't be an easy feat to get through this space debris. Plus, our planet would have to avoid Saturn's moons, all 53 of them. But what if the fall didn't happen, and Earth did turn into Saturn's 54th moon? Then the gas giant's gravitational pull would lead to massive tectonic shifts all over our globe. They would be tearing the planet's crust apart until there's nothing left. Not good either. Both Uranus and Neptune are ice giants. These planets are the same size, larger than Earth, but smaller than Saturn and Jupiter. They both have icy interiors, deep atmospheres, and similar color, very beautiful bluish-green. If either of these planets replaced the Moon, the consequences would be the same. So, let's flip a coin. Okay, it would be Neptune you'd see in the sky one day. Neptune is 14 times larger than the Moon. The planet would look like a bright blue hot air balloon in the sky, not only at night but during the day too. It would appear to be 15 times larger than the Sun. If everything else remained the same, a solar eclipse would seem to continue for ages. Once the Sun vanished behind Neptune's edge, our planet would be plunged into complete darkness for no less than an hour and a half. Neptune is 17 times the mass of Earth, and its gravitational pull is much stronger. That's why our planet would end up as a satellite. Yep, again. It would orbit Neptune slightly further than its own largest moon, Triton. By the way, there would be a great risk of Earth colliding with this space body. But let's assume we were lucky enough not to cross paths with Neptune satellites. Even so, there would be more than enough problems on our hands. Tides on our planet would become 1,000 times more powerful than those caused by the Moon. Neptune's gravitational force wouldn't pull Earth apart, but it would heat our planet up. The seismic activity would increase, setting off earthquakes and volcanic eruptions, and probably louse up the internet too. But the most dramatic scenario would happen should the Moon get replaced by, ta-da, the Sun. See for yourself, the distance between Earth and its natural satellite is about 240,000 miles, and there are between 28 and 43 million miles between the Sun and Mercury. Even though this distance is huge, Mercury is a scorched, deserted place. It has enormous temperature differences, from minus 280 at night to 800 degrees during the day. In other words, if the Sun suddenly appeared as close to Earth as the Moon, it would instantly burn everything off the planet's surface. You wouldn't even have a millisecond to wow at a blazing ball of plasma covering the whole sky. Bring your marshmallows. Solar flares are much longer than the Earth's diameter. Just one of them would be enough to melt the planet's crust, burn its atmosphere, and wipe all forms of life off the face of the Earth. So, given that, I'll bet those chores around the house you've been putting off don't seem so bad now, do they?
The Moon has long been believed to have formed as a result of a humongous impact with the Earth. A Mars-sized celestial body could have driven itself into our planet and made part of its crust shatter. The resulting debris then packed together in a tight ball, which later became our Moon. But there's one question that's been bugging scientists. The Earth's crust is poor in metals, so how come the Moon has so much metal within it? The latest research basically throws the main theory out the window. So we again know nothing about our closest neighbors coming to existence. On the moon, iron is preserved in pristine condition because there's no oxygen. It simply can't rust there. But a couple of years ago, scientists made an unexpected discovery. In the higher regions of our satellite, iron is oxidized and actually rusting. At first, this finding perplexed astronomers to no end. The presence of rust might mean people can breathe, at least in certain areas of the moon. But then the explanation surfaced. Oxygen might have got to the lifeless rock from our own planet. In the absence of atmosphere, solar winds beat the moon relentlessly, and nothing can stop them. These flares could swoop some oxygen from the upper layers of the Earth's atmosphere and carry it all the way to the moon. The molecules then come to rest at the highest points of the moon's surface. That would explain why metals don't get oxidized in the ravines, and especially under the surface of the satellite. Water on Earth is actually a puzzle shrouded in mystery and covered with riddles. The most popular theory is that it was brought to our planet by icy comets and asteroids that left behind not only mighty craters, but the liquid substance, thanks to which we can now thrive. But there's a new advance which suggests another scenario. In space, there's a whole lot of organic matter, and under specific conditions, it could yield so much water, it would be enough to fill our oceans 1,000 times over. Researchers conducted an experiment in which they heated this organic matter and obtained clear water and oil. If this is confirmed in future studies, it could mean that even oil appeared on Earth, not only thanks to fossilized remains of living beings, but came from outer space as well. The climate changes we're witnessing are most probably part of a natural cycle. Researchers from the University of California, Santa Cruz have devised a pattern in our planet's climate variations, and they look like extremely long seasons. Sometimes, these states could last for millions of years, and they're all related to how the Earth is positioned relative to the Sun. The seasons were dubbed ice house, cool house, warm house, and hot house, according to the prevalent temperatures. For the past 3 million years, for example, our planet has been in the state of ice house, since the last ice age was not so long ago. But humanity's actions, adding to the greenhouse effect, have pushed the climate state to warm house much faster than it would have come without us. When it finally comes, the overall temperature on Earth will rise to tropical values, something that the planet hasn't seen in over 50 million years. What a time to be alive! Back to the moon now. You can see it at different places, in different sizes, and even in different colors every night. The size and location are pretty easy to explain. As the Earth rotates around its axis and revolves around the Sun, we see the moon traveling around the night sky and getting either closer to or farther from our planet. What makes it bright yellow tonight and ominously dark red tomorrow is a more complex thing. The natural color of the moon, as seen from outside the Earth's atmosphere, is brownish gray. From the surface of our planet, though, it may vary a lot. When seen right above our heads, it usually looks bright and almost white, because its reflected light passes through a relatively thin layer of the atmosphere. Almost nothing blocks and refracts the shine, so it's very clear. The moon can appear yellow, orange, or even red when it's seen just above the horizon. The effect is similar to what happens at sunrise or sunset, when the sun appears to be red. The light goes a much longer way to reach your eyes from that location, and much of the blue part of its spectrum gets lost. This turns the color of the light into a much warmer variety. Our natural satellite can also appear blue, and the reason for that is the presence of fine particles in the air. They refract the light anyway, so the moon is actually never the way it looks outside the atmosphere. But when they're larger than usual, they turn its color bluish. Finally, there's an extremely rare occasion where the moon can look purple. Nobody actually knows for sure why this happens, but astronomers believe it must be a combination of the atmosphere, dust particles, and maybe something else. There's no clear explanation. Moonquakes aren't something from science fiction. They don't occur as often as on our planet, and when they do, it happens closer to the center of the satellite. Scientists think moonquakes might be caused by the gravity of Earth and the Sun. There are Mars quakes too. For a long time, The red planet had been considered tectonically inactive, but more recent observations have shown it still has weak quakes from time to time. You probably wouldn't even be able to feel them if you stood on Mars's surface, but it means some geological processes are still going on underneath the red and dusty landscape. There's no dark side to the moon. Our satellite is tidally locked with Earth, meaning it's always turned to us with one side, while the other always looks away. The sun is much farther from us than the moon, and we're both turning round and round, warming and lighting this side and that in turn. It means that once in every short while, the moon is lit by the sun from either side. It's just that we can't see it from where we are. Each year, the moon is moving away from Earth because of the interaction between the moon's gravitational force and our oceans. It moves around 1.5 inches away each year, which means in 600 million years, it will be 14,600 miles further from Earth than it is now. The number isn't accidental. That's the time when total solar eclipses will stop happening. There is water on the moon. Not puddles or lakes, but grains of water ice exist in permanently shadowed parts near the moon's poles. Scientists think water got on the moon a long time ago, during a period when both the moon and Earth were constantly struck by asteroids and comets. Those contain water ice. This process may have even helped us get our own lakes and oceans, not just the moon's icy water. Newer research says the moon's interior already had water, and it went to the surface during volcanic activity. The same might have happened on our planet too. For those of you who think the Earth only has one moon, there are 2 more asteroids locked into co-orbital orbits with our planet. The first one doesn't really circle around the Earth, but has some sort of a synchronized orbit with the planet. That's why it looks like it's following the Earth in a stable orbit, while in reality, it has its own specific path around the Sun. The other one follows a horseshoe orbit around our planet. Its specific path brings this asteroid closer to us every 95 years. The moon has its own time zone called Lunar Standard Time. Time is different on the moon, so a year there is divided into 12 days, considering each is as long as our month. Days got names after astronauts who walked on the moon. The moon calendar starts the moment Neil Armstrong stepped onto the moon in 1969. The crust of the moon is not equally thick in all its parts. The average thickness is about 31 miles, but there are much thinner and much thicker areas. This is sometimes due to craters found all across its surface, and there are also big hollow tubes underneath. A lunar orbiter found one such tube several years ago, and it's pretty enormous. Although the tube's shape is irregular, it could swallow an entire football field. Scientists are still unsure what they could find in its depths. It could be a tunnel system, or some geological wonder in there. The most popular explanation of this thing is that it's a lava tube, the likes of which can be found on Earth too. When a lava flow cools, it gets a hard crust, which later thickens and creates a roof over that same lava. It continues to flow, but when it stops, the channel can drain, which results in an empty tube.
So, you want to get as close to the moon as possible without leaving Earth? Easy. Hop on a plane to Ecuador and climb Mount Chimborazo. I know, it may sound weird, but hear me out. Now, Everest is the tallest mountain when you're measuring from sea level, but Chimborazo's peak is actually the closest spot on Earth to the moon. Here's the physics behind it. Mount Everest is over 29,000 feet tall, and Chimborazo is only around 20,000 feet. But the secret lies in how far they are from the Earth's core. You see, Earth is not a perfect sphere. It's chubby in the middle and slightly squished at the top and the bottom. The chubby part in the middle is called the equator. FYI, the country Ecuador actually translates to equator in Spanish. Now you know. The mountain we're talking about, Chimborazo, is located a few degrees from the equator line. So since the squishy sphere is chubbier in the middle part, Chimborazo's peak sticks out farther into space. This means that if you hike all the way up to this mountain's peak, you'll be a smidge closer to the moon than if you hike all the way up Mount Everest. In the North Sea, off the coast of England, there's a tiny platform bobbing around, roughly the size of 2 tennis courts. You might think it's an oil platform, but this is Sealand, the world's tiniest country. The Ruff's Tower platform was built during the first half of the 20th century as a fort to protect English ships. Jump to the 1960s when a guy named Paddy Roy Bates decided to claim this old fort as his own country, naming it the Principality of Sealand. Paddy gave his country everything it deserved: a national flag, currency, a constitution, stamps, and a hoisting swing system. That's how you get into the country, by the way, hoisted all the way up to the upper part of the platform. Today, this micronation is headed by ruling monarch Michael Bates, who is a member of the country's self-proclaimed royalty. I know, right? Why wait in line for the British throne? The nation has its own fan club, who cheer for the country's national soccer club. Their team competes in international tournaments where they usually play with other tiny nations. Although Sealand only has one official resident as of right now, players from other countries join to help out their soccer team. One of the country's supporters also placed a Sealand flag on top of Mount Everest. Having your kitchen in one country and your living room in another, well, this is the daily reality for some locals in Barle. In this town, the border between Belgium and the Netherlands doesn't just run along streets, it slices right through buildings. So, to navigate this setup, a rule was made that a house's nationality is determined where its front door is located. But this solution created its own problems. There's a house where the front door is exactly on the border, giving it 2 addresses, one in Belgium and one in the Netherlands. The owners of this house were given a unique opportunity. They could choose which country they'd like to get their utilities from, like gas and water. And you guessed it, they picked the country where the stuff was cheaper, in this case, Belgium. Down in Senegal, Africa, there's a lake that looks like something straight out of a sci-fi movie. About 18 miles north of the capital, Dakar, you'll find Lake Retba, also known as Lac Rosa. This lake is famous for its bright pink water. Yes, it really is pink, and you can even take a swim if you're up for it. But be prepared, the water is super salty, one of the saltiest lakes in the world with salt levels over 40%. The pink color comes from a species of tiny algae. These algae produce red pigments that reflect sunlight, giving the lake its unique shade. If you want to see the lake at its brightest pink, visit during the dry season from November to June. The rainwater during other times of the year can wash away some of the color. Oh, by the way, there are other pink lakes around the world, like Lake Hillier in Western Australia and Lake Natron in Tanzania. So there's a hill that seems to be on fire all the time. Located in the Arctic region of Canada, the Smoking Hills are a truly unique sight on Earth. Some of the minerals found here are so rare that they've only been spotted on Mars. For at least a couple of hundred years, the ground here has been smoking continuously. At first, explorers thought this was due to an active volcano, but it turns out the smoke comes from something else. The soil in the Smoking Hills contains sulfur and coal, and when these materials mix with oxygen, they can spontaneously catch fire and keep on burning. But don't get any adventurous ideas about visiting. The environment here is extremely harsh, there's toxic smoke, and the temperatures can be dangerously high. So, I'd try Orlando. New Zealand is famous for its stunning landscapes, but it also has a hidden treasure underground. Deep in some caves in the country's North Island, you can find a mesmerizing natural wonder. To see it, you'll need to go down about 150 feet in a series of dark, twisting caves. As you go deeper, you'll enter complete darkness until you reach the cave ceilings, which are lined with tiny glowing creatures. These are New Zealand's native glowworms, which are the larvae of a special type of fungus gnat found only in this country. They shine a bright blue light to attract prey. If you get a chance to tour these caves, it feels like floating through a galaxy, with thousands of these living stars sparkling above and their glow reflecting in the water beneath your boat. It's an incredible sight, like stepping into a magical glowing world. Mexico is home to one of the most amazing caves in the world, called the Cave of Crystals. If you think you've seen big crystals before, wait until you see these. In around 1910, miners in the town of Nika, Chihuahua, yeah, like the dog, discovered a cave full of clear selenite crystals. But it wasn't until 90 years later that they found an even more incredible cave filled with enormous crystals, some as long as 39 feet and weighing up to 55 tons. Scientists believe that 26 million years ago, give or take, hot, mineral-rich water filled this cave, allowing these huge crystals to grow. The Nika crystals are thought to be the biggest in the world, making people standing next to them look teeny in comparison. However, exploring the cave isn't easy. Inside, temperatures reach 136 degrees Fahrenheit. Even with protection, people can only stay inside for 20 to 30 minutes. It's an extraordinary place, but not exactly a comfortable one for humans. Mauritius is famous for its beautiful beaches and clear blue waters. But it also has a stunning optical illusion at its southwest corner that looks like an underwater waterfall. Even though it seems like water is flowing down into the ocean, what you're actually seeing is a trick of the light and the seafloor. The island is on an ocean shelf that's only about 500 feet deep, but just beyond the edge, it drops down to 2.5 miles deep. This drop creates the illusion of a waterfall as currents push sand and particles over the edge, making it look like water is cascading down. So, while it's not a real underwater waterfall, it's definitely a cool sight to see from a boat. Now here's a place that might either give you chills or leave you in awe, depending on when you visit. Near the small town of Gryfino in Poland, there's a forest of pine trees with a strange twist. They're all bent at their bases. During the day, these trees with their sharp 90-degree curves look fascinating and even a bit whimsical. You might even find a comfortable spot to sit on if you're having a picnic. But visit the crooked forest at night, and it takes on a whole different vibe. A thin layer of fog hangs around, making the forest look eerie and a bit spooky. Plus, scientists still don't know why for sure the trees are bent like this. So, would you prefer to see it in the bright light of day or the mysterious dark of night? Ooh. So, Mars has several faces. No, really. Back in 1976, when the Viking 1 orbiter was checking out the red planet, it spotted something interesting, a big structure that looked like a human face. It was in the region called Cydonia. It soon became very popular. A bit later, we also discovered the so-called crown face in Libya Montes. Mars in general has a lot of strange structures on it. In 2022, we spotted a door-like structure there. NASA's Curiosity rover snapped some pictures of a rocky mound called East Cliffs on Mount Sharp. This mound has natural cracks in it, and one of them is about the size of a dog door, like something from an ancient Egyptian tomb. A lot of people hyped that story up. The image was shared widely on social media, making the crack look bigger than it really is. Some people think that it's hinting at extraterrestrial life. But after looking closely, NASA found out that it was just a narrow crack in the rocky terrain. These cracks and gaps are pretty normal in rocky areas, both on Earth and Mars. The crack formed naturally over time, maybe from wind erosion or Mars quakes. Mars is a gold mine of mysterious structures. Recently, we found some strange spiral shapes there. These are giant coils made of lava, and they look like big springs or loops. For years, we weren't sure whether Martian valleys were formed by lava or ice. These lava coils are shedding light on that mystery. Now, thanks to high-resolution images from NASA's Mars Reconnaissance Orbiter, researchers have spotted 269 lava spirals that can't be explained by ice-related activities. What's fascinating is these lava coils are like the ones we see on Earth, like those formed by Hawaiian lava flows. These spirals are so well preserved that they were easily overlooked before. They range from 16 to almost 100 feet wide and are subtle, blending into the dusty Martian landscape. These coils can teach us a lot about Mars's composition, especially its crust and mantle. We still don't know much about those. But Mars isn't the only planet with strange structures on it. For example, Saturn, the gas giant of our solar system, has a fascinating feature at its north pole, a huge hexagon. This is a hexagon-shaped cloud pattern. It's about 9,000 miles long, making it larger than the diameter of Earth. It's thought to be a jet stream made of gases moving very fast, at about 200 miles per hour. This hexagon was first spotted by the Voyager mission in the 80s, and later seen up close by the Cassini mission in 2006. The Cassini mission noticed a change in its color from blue to golden over time. There are different ideas about why Saturn has this thing. One theory suggests it forms because of the way winds move at different speeds near Saturn's poles. Similar shapes were created in lab experiments when liquids were rotated at different speeds. Another idea suggests that a slow spinning stream of air, along with Saturn's special weather patterns, might be responsible. In 2020, we found that when storms are surrounded by winds swirling in the opposite direction, they can create a steady hexagon shape. So far, this is the most likely explanation. Saturn also got lucky with the bizarre moons. One of them is called Lapidus. This moon has a weird feature, a huge ridge that wraps around its middle like a giant belt. This basically makes it look like a giant walnut. Where's my nutcracker? This ridge is incredibly tall by our standards, around 8 up to 12 miles high and stretching 124 miles wide. It covers more than 3/4 of the moon's surface and is considered the third largest mountain range in the entire solar system. Now, we don't have a clue about how this enormous ridge formed. It's unlike anything seen on other planets or moons. There's one idea, though. The ridge might be the remnants of a dead moon. Let's say billions of years ago, a colossal impact shattered chunks of material off Lapidus. These pieces circled around the moon, forming a mini-moon or sub-satellite. And over time, the gravitational pull of Lapidus tore this mini-moon apart, creating a ring of debris around it. As the debris from this ring fell back onto Lapidus, it built up the massive ridge we see today. They think this process happened quickly, maybe over centuries. Saturn's gravity didn't interfere because, luckily, Lapidus was quite far away from it. If Lapidus was closer to Saturn, its moon might have been pulled away. But we do need more simulations to see if this theory is true. Titan, another one of Saturn's moons, also has some weird stuff going on in its methane seas. Scientists have spotted these strange bright spots called magic islands that seem to pop up and disappear over time. We have no idea what they are. Titan's atmosphere is packed with complex organic molecules that clump together and fall to its surface like snow. These magic islands might be snow clumps that soak up methane and sink very slowly. But there's a problem. In water, molecules stick together, which is why stuff can float on top of it. But methane is different. It likes to grab onto other molecules, so it makes any solid thing sink immediately. Yet, these magic islands don't sink. There's a theory that these islands might be like sponges made of ice with lots of holes. When pieces of this holy ice come loose from the edge of the lake, they can float on Titan's seas for a bit before going down under. There are also other ideas, like bubbles of nitrogen gas or waves caused by wind. We need more research to know for sure. Moons like to be weird. Just look at our own one. In 1971, we found a patch with missing soil on our moon, and it looks like a blue lake. They call this mysterious spot Ina. We first spotted it during the Apollo 15 mission in 1971. Later, the Apollo 17 mission took clearer pictures of it. This spot, shaped like a bluish D letter, is one of the weirdest things on the moon. The color comes from special rocks rich in titanium called basalts. These rocks cover Ina's floor and make it look blue. There are also bluish areas near the edges of the mounds inside Ina. Ina is unique and probably has a long history. It might have had volcanic activity, with mounds that are about 3.5 billion years old. It's similar to the surface age of the volcanic field that surrounds Ina. Now, our moon has its own face, just like those on Mars. There's an area near the moon's south pole that looks like a face, but it's just a bunch of craters and shadows that happen to make an image resembling a face when seen from far away. These craters have been there for billions of years and cover about 16% of the moon's surface. Some of these craters might even have water and ice inside of them. You might be wondering why there are so many faces in our solar system. Well, that's because our brains are wired to recognize faces, even when there aren't any. It's a phenomenon called pareidolia. Our brains try to make sense of shapes, So when we see something that looks a bit like a human, our brain turns it into one because it's familiar. Like when you see a shadow figure on a chair with clothes, or even on Mercury. Some people see shapes like Mickey Mouse. So don't worry, it's not extraterrestrial life. It's our brains that play tricks on us, making us see familiar shapes like faces even where they don't really exist.
Soon we might start constructing loads of stuff on the moon. All because India's moon mission has recently detected sulfur near the moon's south pole. This chemical element can come in extremely handy for creating infrastructure on our satellite. It's the first time this chemical element has been discovered on Earth's natural satellite. This sought-after element is mostly found near Earth's volcanoes. Its appearance on the moon speaks volumes about the satellite's volcanic history and its past atmospheric conditions. The mission's rover detected this chemical element less than a week after touching down around 70 degrees from the moon's south pole on the 23rd of August, 2023. This historic landing on the lunar surface made India the fourth country to safely land a mission on the moon. It's also the first spacecraft to touch down so close to the south pole of our satellite. It's an area of strategic importance because it's believed to be home to deposits of water ice. If it turns out to be true, future missions might be able to harvest it and turn this water ice into drinking water or even rocket fuel. For 2 weeks, the lander carried out the data collection, mainly focused on the analysis of the moon's soil and its extremely thin atmosphere. Meanwhile, the solar-powered Pragyan rover started its quest to find frozen water on the moon. As for the lander, it demonstrated another amazing feat on the 3rd of September. The spacecraft fired up its engines and lifted itself for about 16 inches into the air. Then it made a tiny hop to land 12 to 16 inches away from its original position. It's kinda a big deal. Being able to get a lander back off the surface of the moon is essentially for future missions, showing that they can safely return soil samples or even astronauts back home after a lunar mission. In September, the Indian spacecraft was put into sleeping mode. The 14-day-long lunar night was approaching, and the spacecraft wasn't designed to collect scientific data during this period of time. So far, we've learned about a few major findings of the mission. One is related to measuring the temperature of the moon's topsoil at different depths. Intriguingly, the surface of the satellite in that region turned out to be hotter than expected. It was believed that the temperature could be between 68 and 86 degrees Fahrenheit on the surface, but it was around 158 degrees Fahrenheit, way hotter than it should be. The other discovery indicates the presence of several chemical elements, including oxygen. Besides, the data received from the spacecraft confirms the presence of aluminum, calcium, iron, titanium, silicon, and other chemical elements on the lunar surface close to the South Pole. The rover also used special instruments designed to measure quakes and rumbles beneath the lunar surface to detect some seismic activity. It brings us back to the sulfur detected thanks to the rover's spectroscope. Scientists are currently working on figuring out whether this element formed on the surface in a natural way or whether it's the result of volcanic activity or a meteor strike. Another astonishing thing found on the moon is a rock, and it may be the oldest known Earth rock. A 0.7-inch wide chip included in a large rock collection brought to our planet by Apollo astronauts might actually be a 4-billion-year-old fragment of Earth. This finding could help us paint a better picture of the intense pounding early Earth got at the dawn of its life. It could go like this. Soon after the rock formed, an asteroid impact might have blasted it from Earth. At that time, our planet's satellite was 3 times closer to Earth than it is today. The collision was so powerful that this chunk of terrestrial rock found its way to the moon. Later, this fragment got engulfed in a lunar breccia, a motley kind of rock. Eventually, the rock was brought back home to Earth by Apollo 14 astronauts. Even though scientists had found meteorites coming from Mars and the Moon before, it was the first time a rock from the Moon turned out to be a terrestrial meteorite. They also found out that the rock had formed in a water-rich environment at temperatures and pressures corresponding to those at around 12 miles beneath the surface of our planet. In 2019, China's Chang'e 4 mission made history by landing on the far side of the Moon. The mission's rover helped researchers visualize structures hidden deep below the surface of the satellite, revealing billions of years of lunar history. The Yutu-2 rover made this discovery with the help of its lunar penetrating radar. It imaged deep into the Moon's surface and listened to echoes of sound bouncing back off structures hidden from view under the surface of the Moon. It turned out those structures were resting at depths of almost 1,000 feet. The research suggests that the first 130 feet under the surface are made up of layers of dust, soil, and rocks. The instruments also discovered a concealed crater that must have formed after a large object slammed into the Moon's surface. Long, long ago, ancient lava was likely to be flowing deep underground. Researchers believe that the broken rocks around the formation might be debris produced by the impact. They also found that the volcanic rock layers were thinner the closer they were to the surface. Such a thickness variation of lava flows might mean a decrease in the number and magnitude of eruptions over time. So, lunar volcanic activity gradually dwindled since the Moon's formation around 4.5 billion years ago. On the far side of the Moon, there is one of the largest and oldest impact craters in our solar system, the South Pole Aitken Basin. Unfortunately, from Earth, you can only see its outer rim, which looks like a huge chain of mountains. It's a ginormous 8-mile deep dent, stretching for more than 1,500 miles in diameter and covering 1/4 of the Moon's surface. Astronomers are sure that this crater appeared when an asteroid collided with the Moon around 4 billion years ago. And now, look at this gigantic chunk of metal the size of 4 states of Connecticut. As for its weight in pounds, it's enough to say that the number contains 18 zeros. This mysterious mass is hidden about 180 miles under the Moon's surface, somewhere in the middle of the South Pole Aitken Basin. It was discovered when GRAIL, which stands for NASA's Gravity Recovery and Interior Laboratory Mission, gathered data about our natural satellite. When examining this information, scientists noticed that in one place on the Moon's surface, there was a weird change in gravity. After researching this phenomenon, they concluded that something mysterious was weighing down the basin floor there. So far, researchers haven't figured out the origin of the bizarre lump, but there are several theories. One of them claims that the finding is a chunk of dense oxide, which appeared when the Moon was just taking its shape. At that time, the satellite was still covered with ancient oceans of magma, and the lump could be formed at the final stages of its cooling. However, most scientists support another theory, according to which the puzzling mass is part of the giant asteroid that once created the South Pole Aitken Basin. Since the thing is metallic, it's probably the iron-nickel core of the asteroid. There might be a labyrinth of lava tubes on the Moon. Not so long ago, astronomers received the results of underground topography and discovered a massive cave under the surface of Earth's satellite. It could be the result of the lunar volcanic activity that happened more than 3 billion years ago. Streams of lava hardened, creating a thick, hard crust on the outside. But inside, it kept flowing, melting the rock and creating tunnels and caves. Numerous small pits in the Moon's surface discovered by NASA seem to be the openings to such lava tubes. If this theory is confirmed, the underground tunnels might serve not only as a convenient location for human-crewed space missions, but also as much-needed water sources for astronauts.
It's been decades since the last manned moon landing, Apollo 17, which happened in December 1972. Isn't it time we thought about going back to our dusty satellite, and maybe even staying there? NASA has made a promise on this subject. They're preparing to send astronauts on the moon again, perhaps by 2025. This will all happen through a program called Artemis. It's also going to include the first woman ever to experience the lunar surface. Now you might ask, why haven't we done this already? One former NASA administrator said something interesting on the subject. It's not because of scientific or technological issues. Problem was that the potential projects took too long and were just too costly. You see, space travel, especially when it involves humans, isn't easy on the pockets. It's true that, in recent years, NASA had budgets of billions of dollars. Sure sounds like enough money, right? Well, not when you check out their to-do list. That's because they have to consider everything. From telescopes and giant rocket projects to missions also targeting the Sun, Jupiter, Mars, and beyond. When you look at it this way, NASA needs to be very good at budgeting to achieve all those goals. It's not just because of finances, though. The moon itself is quite problematic. It poses real dangers that cannot be taken lightly. For starters, its surface is filled with craters and boulders that aren't easy to land on. Then, there is the moon dust, or regolith, if you'd like to call it by its scientific name. It was created over many years by meteorite impacts. It's extremely harsh and sticks to everything. It can potentially damage spacesuits, vehicles, and systems quite quickly. Also, dealing with the lunar habitat isn't a walk in the park either. The moon has no protective atmosphere. What this means is that for 14 days at a time, the lunar surface is faced with harsh rays from the sun. That period is followed by another 2 weeks of total darkness. All these changes create extreme temperatures, which us humans are not really accustomed to. There are solutions, don't worry. NASA is working on dust and sun-resistant spacesuits and vehicles. They're even developing a system that might supply electricity during those lunar nights. What's even more interesting about this system is it could come in handy on Mars too, once we get there. NASA also needs to draw in really smart people for its projects. Think about it. The average age of the people working for the mission control for Apollo 13 was just 26 years old. And these people had already been part of numerous missions by that time, which means they'd had considerable experience from a very young age. But here's where other individuals can help too. In recent years, it wasn't just NASA who's been working tirelessly to revolutionize space travel. There are many successful people out there with enough resources to join in on these efforts. Some are developing new types of rockets that can land on the moon too. In total, NASA landed 12 people on our satellite. It's definitely one of the most awesome moments in its history, if not the best. And those astronauts did amazing things up there. They brought back rocks, took snapshots, did science experiments, and even left flags behind. These were all important moments of the Apollo missions. But they weren't meant to create a safe place for humans on the moon. Scientists have had this idea of a lunar space station for a long time now. It's only logical. After all, it's just a 3-day trip from Earth. It means we can, technically, afford to make little mistakes here and there, without messing up the whole project. Plus, we'd learn so much before venturing even further into space. A moon base could provide fuel for deep space missions. We could also build telescopes up there and launch them way easier in space. It could also help us in another important project. Figure out how to make Mars habitable too. Not to mention, a lunar space station would help us learn more about the moon's origin. Who knows, it could even bring in some money because of all that fun, exciting lunar tourism. Either way, the Apollo moon program took a lot of work. For starters, let's look at the sheer number of people involved. Around 400,000 from every corner of the states. Not everything was picture perfect, tough. There were two main unfortunate events. Firstly, a fire mishap at the launch pad of Apollo 1. Secondly, an oxygen tank decided to throw a tantrum on Apollo 13, causing severe issues mid-mission. An important part of the project was Saturn V. It is to this day the most powerful rocket flown successfully, being 36 stories high. Still finding it hard to picture? This rocket stood twice as tall as Niagara Falls. Thanks to Saturn V, NASA successfully completed 13 missions. This included chauffeuring 24 astronauts towards the moon, with half of them even having a little walk on its surface. The existing rockets and space shuttles can't go beyond low Earth orbit. In simpler terms, they can't reach the moon with all the gadgets astronauts need to thrive. Current space vehicles are just not capable of carrying that load, at least not since the Apollo missions happened. Regardless, we did make a lot of progress on Earth and are ready to send astronauts to our satellite pretty soon. Here's where the Artemis project comes in. It's a program overseen by NASA. And to make sure it all goes well, NASA previously launched Orion, a spacecraft with no crew on board to orbit the moon and return to Earth. Think of it as an automated test drive. Before we actually send people out there again, we need to make sure all the devices work properly. One day, Orion will be the vehicle that will take astronauts to the moon again. It features a launch abort system to keep astronauts safe in case something bad happens during launch. It also has a service module, which is the powerhouse that fuels and propels Orion and keeps astronauts alive with water, oxygen, power, and temperature control. All these future projects make one wonder, what will life on the moon be like anyway? We can only use our imagination for now. Some say we'll be living in homes straight out of a fairy tale, something like a cozy hobbit hole. Living underground on the moon might be a must. That's due to the scorching temperatures and the lack of oxygen. If you add meteorite threats and the non-stop radiation, it's no wonder we can't just walk on its surface. What about transportation? Big and small companies alike are trying to create the ideal moon ride. If current estimations are current, one type of moon taxi will take off as soon as 2024. Unlike our current rockets, these space taxis won't have to deal with the harsh conditions of re-entering Earth's atmosphere. It will be easier for them to make multiple round trips. To support our lunar living, we'll need to have a special area for space taxis to safely take off and land. Think of it as a landing pad on a firm, flat stretch of moon surface, protected by walls to shield against moon dust. Moving around on the moon's surface will be made easier too. The next generation vehicles we're talking about will have their own controlled environment, which means you won't need a spacesuit while inside. Should feel like stepping out of your space ride for a bit. Then of course, you'll need to put on your spacesuit. Alright, so we've got our homes and our rides sorted. But what about fuel? That's where the moon throws us a lifeline. The moon's lighter gravity means we don't need as much power to escape its pull. Plus, the moon has ice, and that's super handy. We might be able to convert this ice into rocket fuel. We'll need dedicated space gadgets to help gather this ice. One such tool is called Trident. It's like a drill, perfect for digging into the icy moon surface. Additional robotic helpers would then turn this ice into fuel and deliver it to a space gas station. If this works, rockets on their way to Mars could stop by for a quick fuel top-up before continuing their journey.
Consider now
Enceladus.
Saturn's icy moon, one of the most promising places to look for life outside Earth. Scientists have just detected the last one of the 6 necessary ingredients for its formation – phosphorus. This rarest element has been discovered in an ocean on Enceladus. This rare element helps make the soil fertile on Earth. But the concentration of this mineral in the hidden seas on the distant moon might be from 100 to 1,000 times greater than in the oceans of our home planet. It might be because Enceladus's ocean is rich in carbonates, just like soda water, and this soda water is likely to dissolve the phosphates in the moon's rocks. The new discovery also suggests that on other icy moons of Saturn, like Titan, the waters may be loaded with phosphorus too. Why are scientists so excited about this mineral? Well, phosphates, which are compounds that contain phosphorus, are crucial components of life on Earth. DNA, RNA, and cell membranes contain them. But among those 6 elements required for life, which are carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur, phosphorus is the least common. In 2004, the Cassini space probe entered the dust from the second outermost ring of Saturn, called the E-ring. It's made up of ice grains Enceladus ejects. And while studying these ice grains examined by Cassini's cosmic dust analyzer, researchers have detected phosphorus. Enceladus is the 6th largest moon of Saturn. It's not really large, only 314 miles across. This makes the space body small enough to fit inside Arizona. We should try that sometime. Interestingly, when the Cassini space probe first arrived at Saturn, astronomers thought that Enceladus was going to be a frozen ball of ice. But then, surprise, surprise, they spotted plumes of icy particles and water vapor erupting from geysers on the moon's surface. It became clear that there was a global ocean between the moon's rocky core and its icy shell. The same researchers previously discovered that Saturn's moon might be home to complex organic molecules too. Before, scientists thought phosphates could be trapped within the rocky cores of Enceladus and similar worlds. That's why the newest works, which hint that phosphates might also be abundant in the ocean, came as a surprise. Researchers examined 305 ice grains from Saturn's E-ring and found out that 9 of them contain phosphates. And these results were clear and unmistakable. And it's very important because some time ago, phosphine, a compound of hydrogen and phosphorus, was believed to exist in the clouds of Venus. But no one has managed to find any evidence to support this theory. On Enceladus, there's no controversy, and phosphates do exist there. Astronomers consider Europa one of the most promising places in the solar system to search for new life forms. All because this moon has a huge saltwater ocean with a depth of 40 to 100 miles. Yes, it is hidden under a layer of ice that is estimated to be from 10 to 20 miles thick, but it is still potentially habitable. Astronomers claim that plumes of water erupt from cracks in the ice shell and release the contents of the moon's ocean into space. Of course, it's going to be challenging for any life-seeking mission to access such a deep environment. On the bright side, as we are, scientists already have some evidence that there are way shallower pools that probably lie much closer to the surface of the moon. They might be located even less than 1 mile under the ice. And there are 2 great things about this news. First of all, it boosts the odds of life existing on Europa. And secondly, if it's true, it can make it easier for future missions to find these life forms, if there are any. Then we've got Titan, Saturn's largest moon. It's smaller and has lighter gravity than Earth, but it still reminds us of our planet. Like on Earth, nitrogen dominates its atmosphere. Titan is the only other world in our solar system with lakes and rivers. These water bodies are made of hydrocarbons, methane, and ethane. There's also a subsurface ocean of water, but it's located very deep down, and no one has figured out yet if this ocean makes contact with anything under the surface. If it does, it could provide fuel for life after mixing with complex chemistry on the surface. But Enceladus and the other icy moons aren't the only place in the solar system that might host or once hosted life. In 2003, Mars Express, a spacecraft launched by the European Space Agency, discovered methane in the atmosphere of Mars. On our planet, The biggest part of this gas in the atmosphere is produced by living creatures, for example, by cattle digesting food and emitting, gas. However, scientists think that methane was stable in the Martian atmosphere for about 300 years. And then, in 2006, the methane almost entirely vanished from the red planet. And it happened 600 times faster than the researchers' model accounted for. The question? What or who generated the gas, and where did it go? Another Martian mystery is microbes that might be sleeping beneath the surface of Mars. There, they might have been protected from the harsh radiation coming from space for millions of years. Scientists simulated the conditions on Mars in a lab to check if it could possibly be true. And they were amazed to find out that bacteria could easily survive in such conditions for 280 million years. Ooh, that's a long shelf life. This means that if life existed on Mars, we could find the evidence in the planet's subsurface by drilling into the Martian soil. Right now, there is no flowing water on Mars, and cells or spores would simply dry out. Plus, the frozen temperature is similar to that of dry ice. In other words, it's deeply frozen. Let it go. And still, there could be 6 types of bacteria and fungi living underground on the red planet. The most likely of them is nicknamed Conan the Bacterium due to its tough nature. Well, I guess time will show. Anyway, if we don't find life outside Earth in our solar system, we could probably look for it on exoplanets, which is what planets outside our star system are called. Some of them look very promising. The closest to Earth exoplanet is Proxima Centauri b. It's a mere 4.2 light-years away from Earth. Recently, astronomers have found out that this world might resemble Earth even more than they previously thought. It's just 17% more massive than our home planet. It orbits a star that is dimmer and less massive than the Sun. Proxima Centauri b is in the middle of the star's habitable zone. This means that the chances of liquid water and life might exist on the planet. It looks like the exoplanet is tidally locked with its parent star. One of its sides faces the star at all times, and the other is always in the darkness. Scientists haven't figured out yet whether the planet has an atmosphere, is traveling too close to its star, and completes one orbit within 11 Earth days. The radiation from the star might be pulling the planet's air away. If this is the case, Proxima Centauri b isn't likely to have liquid water on its surface. Gliese 832c is 16.2 light-years away from Earth. In the cosmic scheme of things, it's a stone's throw away. This exoplanet is 5 times as massive as Earth and travels much closer to its parent star. That's why a year on this planet lasts a mere 36 days. But since this star is a red dwarf, much cooler and dimmer than the Sun, Gliese 832c gets as much light and heat as our planet. At the same time, it's still unclear if it's similar to Earth. The planet probably has a much thicker atmosphere that creates a runaway greenhouse effect. This phenomenon occurs when a planet absorbs more heat from its host star than it can release back into space. This means that Gliese 832c is more likely to resemble scorching hot Venus rather than the relatively cool Earth. Hey, I'm cool with that.
NASA has some incredible plans for the Moon. For example, their next ambitious lunar program, Artemis 2. They've set their sights on landing astronauts, including the first woman and the next man, on the Moon by 2024. Artemis is all about building a sustainable presence on the Moon. They're planning to establish a lunar gateway, a sort of space station in lunar orbit, which will serve as a jumping-off point for lunar landings. And let's not forget about the cool lunar landers. Scientists are developing the mighty Space Launch System rocket, which will launch the Orion spacecraft carrying astronauts towards the Moon. Then there's the Human Landing System, a snazzy lunar lander that will gently touch down on the Moon's surface, allowing astronauts to explore and conduct amazing scientific experiments. And NASA isn't going alone this time. They're teaming up with international partners, like the European Space Agency, to make this lunar dream a reality. But all these wonderful dreams might be ruined by something that seems super small and insignificant at first. Picture this: no atmosphere, no air to breathe, and suddenly, a mysterious haze and radiant beams of light appear at sunrise and sunset. It's as if the moon is putting on a celestial show. But there is a twist to this beauty. During the Apollo 17 mission in 1972, this beautiful sight made one of the NASA astronauts, Harrison Schmitt, sneeze and made his eyes water. He called it lunar hay fever. This mysterious fever affected all 12 moonwalkers. From sneezing fits to stuffy noses, those astronauts experienced symptoms as if they caught a cold. It took days for the reactions to fade away. This event led to a discovery about lunar dust and its darker side. When scientists found out about these rays, they rolled up their sleeves and delved into their origins. And here's what they discovered. Those radiant bands of light were actually caused by sunlight sneaking through layers of teeny tiny lunar dust. The dust was composed of small particles and sharp glass shards and was lurking everywhere. And it turned out that this lunar dust was a sneaky villain. It brought a whole host of problems. Astronauts who found themselves with impaired vision were just the beginning. The troublemaker went even further, damaging precious machinery and causing electronic malfunctions. It even had the audacity to corrode components and smelled like burnt gunpowder inside the spacecraft. Yikes. It clings to everything, coating surfaces like a mischievous blanket. It can clog up equipment, get into delicate machinery, and even mess with astronauts' spacesuits. In 1972, things got really hairy again. The Apollo 17 astronauts faced a nightmare. After just 22 hours of gallivanting on the lunar surface, their spacesuits suffered irreparable damage. Yes, you heard that right. Irreparable. The dust diminished astronauts' mobility, making it harder for them to move around and perform their moonwalks with grace. And no matter how hard they tried to clean it off, it clung on for dear life, leaving the spacesuits in a sorry state. So, as you can see, it poses some serious challenges for future moon missions. But our intrepid scientists aren't giving up. To solve this problem, they have to understand how lunar dust forms and why it's so darn clingy. They found out that it all begins with meteorite impacts. When these space rocks crash into the moon, they generate a fine dust that fills the air. Sometimes these impacts even cause minerals to melt, forming sharp glass shards that mix with the dust. Talk about a moon makeover. The dust is also filled with silicate, a material commonly found on volcanic planets. Silicate inhalation can cause serious lung problems for Earth's miners, so you can imagine the trouble it can cause on the moon. A recent study found that even a scoop of replica moon dust was toxic enough to destroy up to 90% of lung and brain cells exposed to it. But it gets worse. The low gravity on the moon allows those tiny particles to float around for much longer, penetrating deeper into the lungs. Imagine breathing particles 50 times smaller than a human hair for months. That's a recipe for trouble. And you see, on the moon's surface, things are a bit different than here. There are no rainstorms or strong gusts of wind to blow this dust away. There is also no atmosphere to protect the surface. So without the natural forces of wind and water erosion like we have on Earth, these dry particles stick around persistently. And to make matters more electrifying, the moon is constantly showered by radiation from the sun. This exposure gives the dust an electric charge. The solar winds create positively and negatively charged particles. The particles then buzz around, repelling each other and giving rise to those radiant bands of light that the Apollo 8 astronauts witnessed. It's like a disco party on the moon. ESA, the European Space Agency, has gathered a team of experts to study the lunar dust. They're working with simulated moon dust mined from a volcanic region in Germany to understand its behavior and effects. Engineers also need to find a way to protect future astronauts and equipment. Engineers in NASA want to create spacesuits that can survive not 1, not 10, but a whopping 100 extravehicular activities on the lunar surface. That's like spending 800 hours out there, exploring and having a blast. Besides that, NASA initiated the Breakthrough, Innovative, and Game-Changing Idea Challenge in 2021. It was open to clever university students from all over the world. These young minds put their thinking caps on and unleashed a wave of innovative solutions. For example, they proposed using special fibers that conduct electricity, inspired by fluffy chinchilla hair. Just like how chinchillas stay dust-free, these fibers would help keep the lunar dust at bay. A furry friend lending a helping paw, isn't that adorable? Another bright idea involved an electrically charged brush activated by UV radiation. It's like a magical wand that zaps away the dust with a flick. Abracadabra, lunar dust be gone. And let's not forget the fabric inspired by clever insects. These insects have pollen-collecting structures that repel unwanted dust. So our ingenious students thought, why not mimic that? They designed a fabric with similar properties, creating a shield against the sneaky lunar particles. What's remarkable about these ideas is that they all use the power of charge to fight the dust. They cleverly repel it from the spacesuits, keeping them clean and protected. And even though all these ideas sound pretty great, scientists in NASA unleashed another, even better solution: carbon nanotubes. It's a great way to revolutionize spacesuit fabric. What makes these carbon nanotubes so special? Well, they possess some amazing superpowers. First off, they're superconductive, meaning they can carry electricity like nobody's business. It's like having a lightning bolt trapped inside a microscopic tube. Not only that, but these carbon nanotubes are tougher than the toughest meteors. They have the strength to withstand the harsh lunar environment, where even a speck of dust can cause trouble. Imagine having a suit made of a material that's stronger than Superman's cape. So, NASA's scientists decided to weave these extraordinary carbon nanotubes into the spacesuit fabric. The electrodes were carefully integrated into the outer layer of the fabric, making it a force to be reckoned with. But how do they banish the lunar dust? Well, here comes electrifying science again. When activated by a special alternating current, the electrodes create powerful electric fields. These fields work like magnets, repelling both charged and uncharged dust particles away from the spacesuit. Picture this like a dance party, where the dust particles are the uninvited guests, and the electric fields are the bouncers, swiftly escorting them out. Thanks to this technology, lunar dust doesn't stand a chance against our astronauts. Also on the bright side, the lunar soil can be used to make bricks for shelters. It can also help extract oxygen for astronauts to survive on the moon for long periods of time. When life gives you lemons, make a lemonade, right? So, let's cheer on our NASA Dream Team as they embark on this epic lunar quest. Let's hope that they succeed in their findings, and the next moon mission won't be a big problem. Stay tuned. Put on your shades because Mercury is a hotspot. From the surface of this planet, the sun looks 3 times bigger than it does from Earth, and the light is 11 times brighter. Mercury may spin slower than Earth, but it still knows how to have a good time. One day on this planet lasts a whopping 59 Earth days. But don't worry, a year on Mercury is only 88 Earth days long, so if you want to feel like a centenarian, just divide your age by not 0.25 or multiply it by 4. This way, you'll get your approximate Mercurian age. Easy peasy. And let's not forget about Mercury's funky orbit. For every 2 orbits around the sun, it spins twice. That means each hemisphere gets a full year of daylight followed by a long night. Time zones would be a mess on this planet, so we'll just stick to GMT. Ugh, did anyone forget to take out the trash? Why does it smell of rotten eggs in here? Sorry, it's because we're on Venus now, and these stinky clouds don't smell like roses. Any planet's day is basically just how long it takes for it to do a full spin on its axis. Well, Venus takes its sweet time with this, way slower than Earth, in fact. So a day on Venus lasts a whopping 243 Earth days, or almost 6,000 hours. Now here's where things get a bit tricky. Because Venus's day is so long, we actually use Earth's day as standard for keeping time on the planet. That means there's only one time zone for the whole planet. Seems convenient, huh? Venus's year is about 225 days. So if you were celebrating New Year's Eve on Earth in the year 2000, that would have been Venus's year 3251. So to keep track of time of Venus, we can use the local year, made up of 225 Earth days, but every 3 years or so, there's an extra short year made up of only 224 days. Not that confusing. We have leap years on Earth too, but it works a bit differently. We've made it to planet Earth. Woohoo! How many time zones do we have on this big blue ball? Give me a drum roll. 24. And did you know that we can actually mess with time a little bit? Yup, in about 80 countries, mostly in Europe and North America, we have something called daylight saving time. It's where we move our clocks forward an hour during the summer so we can soak up all that sweet, sweet sunshine. But beware, each country has its own rules about DST. So make sure you don't get caught snoozing when you're supposed to be working. And get this, some regions even have time zones that differ from UTC by half or quarter-hour increments. Can you imagine that the moon is getting its own time zone? The European Space Agency announced on Monday that it's time for the moon to have its own synchronized time zone. With more and more countries and private companies planning missions to our lunar neighbor, it's important that we all speak the same language when it comes to timekeeping. Right now, each mission carries Earth's coordinated universal time with it, which is fine when there are only a few missions happening at once. But with dozens of moon missions planned over the next few years, things are going to get tricky. We need a system in place to make sure everyone's on the same page, or we'll end up with different spacecraft out of sync with each other, and nobody wants that kind of chaos in space. Precise timekeeping is super important for communication and navigation, so we need to figure out a way to make sure everyone's on the same page. The ESA hasn't figured out exactly what form this new lunar time zone will take, but they're working on it. Should there be a single organization responsible for keeping lunar time? Or should we let the moon set its own time? And what about more granular time zones based on the sun's position? These are all important questions that need to be answered. When it comes to a day on Mars, it's not too different from a day on Earth. We're talking 24 hours, 39 minutes, and 35 seconds. A Martian year is 1.8 Earth years, which means the Earth year 2000 happened in Martian year 1063. Almost forgot. The Martian year has 668 local days. Phew! We sorted out the Martian calendar, but Mars will need local time zones. Because of its elongated orbit, the difference between summer and winter hours will be significant. Daylight saving time will be a thing on Mars. A year on Jupiter lasts almost 12 Earth years. Yeah, that's like a lifetime in dog years. But don't worry, they've got 12 seasons to keep things interesting, each almost as long as an Earth year. But a day on Jupiter only lasts 9 hours and 55 minutes. Also, since Jupiter doesn't have a solid surface, the clouds move at different speeds, so two free-floating atmospheric stations could experience different days. Hey, if we lived on Jupiter, we'd be in bad need of some cool app tracking all those things. Anyway, if we ever terraform Jupiter's region, most of the population will still live on Jupiter's moons, because the atmosphere is just too wild. And get this, the moon's revolution periods are connected, so we can use the same day counting system for all of them. On Io, we can have 2 standard Jovian days in one Earth day. How do we break that down? Well, we could have a minute of 53 seconds and an hour of 103 minutes. Or we could just stick with Earth's minute and hour and have a day that's 21 hours and 13 minutes long. How old are you? I'm 200 days old, and you? Sounds odd to you, Earth dweller, but dudes on Saturn count their age in days. A year on Saturn is crazy long, like more than 29 Earth years. Kiddos would only get a fraction of a year, while the oldest folks might get a whopping 3 years. So to keep track of time on Saturn, we could divide up a Saturnian year into 29 or 30 seasons. Oh, and fun fact, Saturn doesn't even have a solid surface, just rotating clouds that spin at different speeds. But we could still set up some cool research stations or helium extraction balloons to float around up there. One Uranian year lasts a whopping 84 Earth years. So to make things easier, we'll stick to using Earth years for our calculations, and natural Uranian years can be used for special occasions, like reaching 1 Uranian year old. As Uranus doesn't have a solid surface, the rotation period is all over the place. Only science missions and helium mining companies are brave enough to venture into the atmosphere. And get this, each moon has its own day and date system. Pretty confusing. Most people won't ever celebrate 1 Neptunian year old. 1 year on Neptune is like that's way too long for us humans to stick around. But don't worry, we'll still bust out the confetti and party hats for special occasions, like when it's been 2 whole years since the first spaceship hit up Neptune. As for the rest of the time, we'll just use Earth years for all our business needs. Pluto takes a whopping 240 Earth years to orbit the Sun, which is way too long to use as a year in our everyday lives. A day on Pluto is almost like a week on Earth. So, to keep track of time, we're going to divide that into 6 standard Plutonian days, 3 of light and 3 of dark. That means a standard day on Pluto will last slightly more than 1 Earth day. Now, because Pluto's axis is super tilted, using time zones would be pointless. So we'll just use 1 time zone for the whole system. Easy peasy. As for the standard Plutonian year, it'll be almost the same as the Earth year, about 343 days. But once in 10 years, we'll throw in an extra day just for kicks. That's all for now. See you on Pluto.
Okay, I officially give up on the hope that the moon is made of cheese after all. Wow, not even Gouda. The shiny lunar ball, or a curved banana, or half of a coin, depending on what phase it's in, has different layers inside, just like Earth. One of these layers is called the inner core. About 20 years ago, scientists were observing how the moon rotates. Using that data, they concluded that it had a fluid outer core. But the inner core was hard to study, so they didn't know if it was solid like a rock or molten like a hot liquid. But things are clearer now. Astronomers have collected data from different missions, including the Apollo missions, where astronauts went to the moon and gathered information themselves. Plus, they've used a special technique called seismic data. This method is all about studying how sound waves move through things. Take earthquakes on our planet as an example. When an earthquake happens, it creates waves that travel through the ground. Scientists can detect and analyze these waves to learn more about Earth's interior. The same idea can apply to other objects in our solar system, or planets, or, in this case, the moon. When quakes or moonquakes happen, they generate sound waves, and by carefully listening to and studying these waves, scientists can create a detailed map of what's inside the object. They can figure out things like different layers, what they're made of, and how they're arranged. To check the moon's deep interior, scientists also use something called laser ranging. This method measures the distance between the surface of the Earth and the moon very precisely. And ta-da! Our natural satellite's inner core is a dense, solid ball made of iron, just like Earth's. It's about 310 miles wide, which is nearly 15% the size of the entire moon. Researchers also have stumbled upon evidence that supports the theory that the layer between the moon's surface and its core, called the mantle, has been moving around as the moon evolved over time. This movement is something we call lunar mantle overturn, and it could explain why we find elements rich in iron on the lunar surface. Mantle material ends up being carried upward, and the volcanic rock remains in the moon's crust. Some of the materials in this rock were too dense, like me, so they just sank back through the lighter crust material all the way to the core mantle boundary. It's like a cycle where the moon's mantle material goes up during volcanic activity, carries iron-rich elements to the surface, and then sinks back down. There's another mystery scientists have been trying to solve: what caused the moon's magnetic field to weaken and nearly disappear over time? It seems that now that we know about the iron core and the global mantle overturn, we might get some more answers about the moon's magnetic field. Knowing what the inner core is like can help us better understand the moon's history as well as the history of our entire solar system. Now, one of the theories that's widely accepted about the origin of the moon says there was a massive collision between Earth in its early stages and another mysterious object in our solar system. It's called the Large Impact Theory, and this collision was so strong it ripped off a big chunk of the primitive molten Earth. I mean, not so big compared to what's left. If you put a US nickel next to a green pea, you get a good idea of how big our planet is compared to the moon. Now, this chunk was set into orbit around our planet, and this might have happened about 95 million years after our solar system formed. The object that collided with Earth could have been about 10% the mass of our home planet and roughly the size of Mars. Well, it makes sense. Earth and the Moon do have similar compositions after all. Of course, there are other ideas about how the Moon formed. One says that the gravitational force of our planet captured it. This means that the Moon was just an object innocently passing by when suddenly it got attracted and pulled into Earth's orbit. There's even a hypothesis that Earth stole the Moon from Venus. Ooh. In that case, the moon shouldn't complain. I guess the view is way better here. So yeah, the moon and Earth are similar when it comes to rocks and some minerals. But the moon doesn't have the same atmosphere as our planet. Its atmosphere is thin and consists of some weird gases that include potassium and sodium, which is not something you can find in the atmosphere of Mars, Venus, or Earth. And the rocks on the moon don't contain water, but that doesn't mean there's no water at all up there. A long time ago, in the 17th century, astronomers saw large dark spots on the moon's surface. One of these astronomers thought these spots looked like oceans, and he called them maria, which means seas in Latin. Other astronomers also made maps of the moon, and they used the term maria to describe these dark spots. For example, Mare Tranquillitatis translates to Sea of Tranquility, where Apollo 11 made its touchdown. But it seems those dark spots are not actually oceans. They are plains made of hardened lava that erupted long ago. These volcanic eruptions left behind smooth flat areas called basalt plains. In the late 1800s, one sky watcher studied the moon and found it didn't have an atmosphere. Without an atmosphere, there are no clouds and no air to keep water from evaporating. So scientists thought that any water on the moon would just disappear right away. They believed the moon was totally dry. But then, in 1961, one physicist had a different idea. He pointed out there could be water on the moon in special areas called permanently shadowed regions. These are spots on the moon where the sun doesn't shine, so they stay dark all the time. Water ice could exist in these dark areas because they're extremely cold and the ice wouldn't evaporate. But when astronauts from the Apollo missions went to the moon, they brought back soil samples, and scientists found no signs of water in them. So everyone went back to thinking that the moon was completely dry. In the 90s, NASA focused on these shadowed craters and found high concentrations of hydrogen, which meant there could be ice at the moon's poles. They still weren't certain, so they kept digging and after a while found hydrogen trapped inside tiny beads of volcanic glass. Since there are no active volcanoes on the moon today, which means water probably was present on the moon when these volcanoes erupted long ago. Plus, there could be way more water back in the early days of our moon. In 2020, NASA's SOFIA mission showed us what we'd been looking for a really long time. There is water on the moon after all. It turns out the water is hidden within the grains of lunar dust or sticking to the surface in the sunlit areas of the moon. So there are no oceans like we have on Earth, but at least there's something. The question remains, how did water even get there? It seems the moon had a chaotic history back at the time when it was forming, as probably most of the planets and moons in our solar system. So there is some evidence that water came there from comets hitting its surface back in the old days, or maybe even keeps on coming from those that are slamming into the moon right now. We're talking about a chaotic situation where icy micrometeorites collide with the moon's surface, and dust then makes an even bigger mess when interacting with the solar wind. But we're waiting to find out more about this. Because, as we all know, when you mention water, you also inevitably talk about life. That's why we want to know more, for instance, about all that ice hidden in polar craters on the moon. Maybe it can teach us more about how life developed on Earth. Maybe comets brought all the necessary elements here. Then, what if there are some of those elements stuck in the ice on the moon, too?
What if we lived in a world where the moon and the sun swapped places? Yeah, I know what you're thinking. The consequences would be staggering and catastrophic. But here's an interesting take. What if we somehow survived all this? What would our life look like in such a new world? And what would happen to the solar system? Time to find out. Let's start with the moon. Did you know that the moon is responsible for the tides on Earth? You know, that thing where the ocean goes in and out like it's playing a game of beach volleyball? All thanks to our satellite's gravitational pull. The moon also helps stabilize Earth's rotation. It's pretty important if you don't want to end up like a certain planet that spins on its side. looking at you, Uranus. Plus, it acts as a shield, protecting us from some of the more harmful cosmic rays, asteroids, and space debris. It's like our personal bodyguard. And without our satellite, we might not be here cracking jokes and enjoying life at all. Some scientists think that the moon played a crucial role in the development of life on Earth. Without its gravitational pull, we could have a crazily erratic climate. Also, the moon could have redistributed water across our planet, and we all know that water means life. As for the sun, we all know how important it is. It provides light, heat, and energy for all the planets. But, just like any good party host, the sun can get sometimes a little too intense. Never forget that it's an extremely powerful and massive star, with a surface temperature of about 10,000 degrees Fahrenheit. If it wasn't for our ozone layer, we would all get burned instantly. The distance between the Earth and the Sun is about 93 million miles. Scientists took this distance and turned it into a unit of measurement, 1 astronomical unit, or AU. The closest distance that the Earth could approach the Sun without being completely destroyed is about 0.9 AU. At the same time, if we move too far, further than about 1.2 AU, our planet will turn into a snowball. So we got pretty lucky with our location. Meanwhile, the distance between Earth and the Moon is about 0.002 AU, or 240,000 miles. It's super close to us. Now that we know how important these two are, and how much their position affects our world, let's try to swap them. Surely nothing bad will come of it. First, let's imagine for a moment that the Sun was in the Moon's place. You probably already know what will happen to us. The intense heat and radiation from the Sun would be like the world's worst sauna, with the temperature on Earth rising rapidly. Any living thing on Earth would leave behind nothing but a pile of ashes. But the destruction wouldn't stop there. The atmosphere and oceans would be stripped away by the solar wind, leaving the planet exposed and vulnerable to the radiation and particles coming from the Sun. It would be like a giant space hairdryer on full blast, with Earth's atmosphere and oceans being blown away instantly. Forget about melting ice caps. The entire planet would be one big puddle. But that was a scientifically accurate answer. Boo, boring. Now, what if we could somehow survive this catastrophe? Like, what if we had some super advanced technology to protect us from being fried to a crisp? First up, even if our planet somehow survived, things would still get pretty toasty, since the Sun would still emit way more heat and energy than the Moon. Also, unlike the Moon, which goes through periods of darkness during its lunar night, the Sun has a constant energy source through nuclear fusion. So at least we wouldn't have to worry about freezing every night. We'd just be sweating buckets in our sleep. Of course, all this extra heat would have some serious effects on our ecosystems. Plants and animals would have to adapt to survive. And we might see some major changes in the way life on Earth operates. Imagine the confusion of nocturnal animals. Without the Moon, they would have no idea how to navigate or hunt. So, what would we do in this new, super hot world? Well, maybe we could build some seriously high-tech greenhouses to trap all this heat. Or we could use some giant mirrors, or other reflective surfaces, to manipulate the amount of sunlight that Earth receives. Next, we have the Sun's gravity. Remember how we said that the Moon's gravitational pull is just right for stabilizing Earth's orbit? So, if we replace it with an entire star, things would get pretty wacky. We're talking about extreme changes in seasons, climate, and all sorts of weather-related shenanigans. Your everyday life would look like it's trying to do the cha-cha slide during an earthquake. The Earth's rotation would also speed up drastically. This means shorter days, longer nights, and lots of confusion with working hours and birthdays. So, is there any way to fix this? Well, hypothetically, we could use some massive spacecraft or other technologies to artificially adjust Earth's orbit and rotation. For example, we could launch rockets or space tugs that would slowly push our planet into a new orbit that's more stable and consistent. And that's not all. All this gravity play would also mean new tidal waves of epic proportions. We're talking waves so high that surfers would need oxygen tanks just to catch a ride. Imagine trying to sail a boat through a hurricane while riding a bucking bronco. Yeah, yeehaw! The moon also mixes up nutrients in the ocean and helps support marine life. So if we swap the sun for the moon, those nutrient-rich waters would be a thing of the past. The ocean would become a stagnant, lifeless soup, with nothing but algae and plankton to keep us company. We'd have to resort to eating seaweed sandwiches and drinking desalinated water just to survive. And let's be real, nobody wants to live in a world without sushi. So what do? Well, we could try to somehow artificially create tides or mimic the moon's gravitational pull on the ocean. Like using pumps or other mechanisms to move large volumes of water around in a way that creates a similar tidal effect. Or we could try to help marine life to adapt to the new, less nutrient-rich ocean. Maybe developing fish farming or aquaculture. Finally, don't forget about radiation. The sun is basically a radiation factory. It could seriously mess with our health and electronic devices. You think your phone is fragile now? Imagine what would happen with it under a giant solar flare. So we'd need some seriously advanced shielding technology to protect us. We're talking materials that can withstand temperatures hotter than a jalapeno's backside, and magnetic fields powerful enough to deflect charged particles. Oh, and tons of sunscreen. In summary, if we replace the moon with the sun and somehow manage to avoid catastrophic consequences, it would be a completely different world than what we know. But it wouldn't just be the Earth that would feel these effects. So what would happen to the rest of our solar system? For starters, if the sun, with its crazy gravitational pull, took the moon's place, it would start seriously messing with the other planets' orbits. They might be sent careening off in random directions, like bumper cars. The planets would also have some taste of the sun's fiery personality. They would have to deal with all the radiation and charged particles. Lastly, the sun's magnetic field is incredibly strong, and if it took the moon's place, the other planets would be forced to dance to its tune. This could cause electrical storms, auroras, and other crazy electrical effects everywhere. And what would happen to the moon itself? Unfortunately, its reign in the center of our solar system won't last too long. Most likely, it will either start orbiting the sun and be eaten by it, or simply fly away like a free birdie. So there you have it, a cosmic prank gone horribly wrong. What can we say? Let's just be thankful that such a scenario isn't physically possible, and instead enjoy the beautiful moon and the life-giving sun from a safe and comfortable distance.
The first trip intending to land on the moon made by human mammals took 3 days, 3 hours, and 49 minutes. The Apollo 11 astronauts needed to travel some 240,000 miles to get there. Their plan was to touch down on a place on the moon called the Sea of Tranquility because it had good visibility and the terrain there was pretty smooth. Well, up until the last few moments of the flight, when all these big craters appeared that they had to avoid, they finally landed with just 30 seconds of fuel left. Ooh, that's called cutting it close. Hey, how would you like to land in your jetliner with only 30 seconds of fuel left? So, now you know. Later that day, July 20th, 1969, Neil Armstrong stepped onto the lunar soil, saying, "That's one small step for a man, one giant leap for mankind." The astronauts were planning to sleep before the first moonwalk, but they chose to go outside earlier than scheduled. They obviously couldn't sleep. I mean, could you? Since that first visit, our lunar satellite has accumulated quite a collection of memorabilia from Earth. Let's look at some of the most important and weird stuff that humans have left on the moon. Take footprints, for starters. I know they're not technically objects, But the marks left by Neil Armstrong and Buzz Aldrin do show that humans have been there, just in case someone or something else drops by. Since the moon doesn't have any wind or rain, the footprints should still be relatively untouched. NASA put in a lot of effort to make sure these footprints stay protected, as well as the location of the initial moon landing. Rules were set into place for future missions to make sure they wouldn't alter the initial site, as it's an important piece of history, kind of like a national park that you can't get to. Now, astronaut Charles Duke wanted to leave a photo of his family on the surface of the moon. If that didn't make him the best dad ever, I don't know what would. He did take his family to the moon, right? On the back of the picture, he wrote that he had come from Earth. He also added the date when he landed on the moon, which was April 20th, 1972. Now, there's a good chance that his family is no longer visible in the picture today. Because of the exposure to strong solar radiation, the colors in the photo have likely faded away by now. To this day, Charles Duke remains the youngest person to visit our moon. He was 36 years old at the time of his mission. Now, there are many flags on the surface of the moon too, but the flags left there must have had a similar fate to Duke's photo. They're most likely discolored by now. During each lunar landing, a flag was planted as a tradition started by Apollo 11. This tradition continued with all future Apollo missions. The flags were made using metal poles to stretch the flag out so they could be seen on the moon. But since there's no wind, they never move. Back in the 1600s, astronomer Galileo Galilei dropped two objects of different weights from the Leaning Tower of Pisa to show that the speed of the fall would be the same. In 1971, astronaut David Scott repeated the experiment on the moon and proved Galileo's theory correct. He dropped a feather and a hammer at the same time, and as predicted, they both landed on the moon's surface simultaneously. Fun fact, the feather came from the Air Force Academy's Falcon mascot named Baffin, with its permission, of course. These objects were both left on the lunar surface. Now, what about art pieces on the moon? We've left some of those out there as well. The Fallen Astronaut sculpture was made by a Belgian artist and left behind by the astronauts of the Apollo 15 mission. It was a small statue requested by David Scott, the head of the mission. Scott said the statue was to memorialize the astronauts and cosmonauts who gave their lives for the advancement of space exploration. Meanwhile, astronaut Alan Shepard even played some golf on the moon during his mission on Apollo 14. He brought a golf club head, yes, he got permission first, and attached it to a tool. Then he tried to hit two golf balls. Hey, it's hard to do in a clunky spacesuit. He did better on the second one. It's safe to say that he didn't bring the golf balls back, and they should still be there on the moon. There's yet a message from Queen Elizabeth II there. The monarch prepared a message which accompanied Neil and Buzz to Tranquility Base during the Apollo 11 mission. It was written on a tiny disc the size of a coin and also featured messages from over 70 other leaders from all over the world. I'll bet the printing was really small. Her message said she was proud of the astronauts and their accomplishments and hoped their journey would benefit all of humanity. The disc was then placed where Armstrong and his team first landed on the moon. After they returned, they met the Queen at Buckingham Palace. Their encounter was memorable too. Neil Armstrong almost couldn't speak to the Queen at all because he had a cold. Another astronaut named Mike Collins was so nervous about the protocol, he almost fell down the stairs. Now, some objects that exist today on the moon weren't left there on purpose. One of the most interesting moments of the Apollo 11 mission was when Neil and Buzz were getting ready to go back to Earth. They had to chuck everything they didn't need so they wouldn't be weighed down at liftoff. They also needed to store all the rock samples they had gathered from the lunar surface. This created a toss zone that archaeologists could potentially study one day. Waste like this acts as a timeline for Earth's history, but it can also help us understand what happens to objects that spend a lot of time on the surface of the moon. Now, most astronauts became pretty sentimental when strolling on the lunar dust, and who could blame them? They were thousands of miles away from their families. So that's why, in 1972, NASA astronaut Eugene Cernan wrote his daughter's initials, TDC, in the dust on the moon, and gave a speech before leaving. He said, "We leave as we came, and hopefully we'll return with peace and hope for all." Unfortunately, this marked the end of the Apollo lunar missions. Technically, his daughter's initials should still be there on the surface of the moon, just like all the astronauts' footprints. Can you believe it's been more than 50 years since people started exploring the moon? No worries though, as NASA's been preparing for future lunar explorations for quite some time. This new mission is called Artemis, and it aims to build some sort of settlement out there. This way, the moon can be studied in safe conditions for longer periods of time. For starters, NASA launched Orion, a spacecraft without a crew on board, to orbit the moon and come back to Earth. This was a test drive. Before NASA transports people to the moon again using newer technology, all safety measures need to be worked out and confirmed. But one day soon, Orion is going to take astronauts back to the moon. One cool thing about this spacecraft is that it comes with a launch abort system, which is meant to keep astronauts safe in case something goes bad during the launch. It also features a special service module, which is like a battery that fuels and propels Orion through space. It also supplies astronauts with water, oxygen, and power, and provides temperature control. But Artemis also looks to build a long-term human settlement on our satellite somewhere around the 2030s. However, searching for a cozy place on the moon isn't as easy as you'd think. Thankfully, NASA specialists produced an ingenious idea. They found some lava tubes on the surface of the moon, and they have pretty steady temperatures inside. The main problem with the first moon landing back in 1969 was extreme temperature fluctuations. So these caves might be the perfect solution. Not only is the temperature in there suitable for humans, but they could also help shield astronauts from cosmic rays, solar radiation, and meteorites. It's also good news that we have similar structures here on Earth. Before we get back to space, we can study them to better understand those found on the moon. Here on Earth, these holes form once the top of a stream of lava solidifies, and the molten rock inside drains away, creating this tube.
The Moon. A beautiful, natural satellite with some mysterious dark splotches. We always see only one side of it, so we're used to this image. It's hard to imagine the Moon looking any other way. But it used to be different. Oh ho ho, it used to be so different. Picture this. A huge incandescent satellite in the sky that is causing constant tsunamis. I suggest we go very far into the past to see what the Moon was like many, many years ago. The Moon formed around 4.5 billion years ago. At that time, our green-blue planet was still a red-hot, insanely unstable piece of rock flying in space. We didn't have the Moon yet, and a day on our planet only lasted 6 hours, which meant only 3 hours of daylight. Volcanoes erupted all over the place, releasing poisonous gas into the air, and a bunch of meteorites regularly crashed into the planet. At the same time, 4.5 billion years ago, the so-called Big Splash occurred, or, as scientists call it, the Giant Impact Hypothesis. It claims that once an object the size of Mars crashed into Earth. Mars is about 2 times as small as our planet, so the blow wasn't too bad, but it was quite catastrophic. This powerful impact tore off part of the outer layers of that Mars-sized object and Earth. The very core of this space body merged with Earth's own dense core, and a huge number of fragments of Earth flew into outer space. So, this was the beginning of our Moon, or, saying in a scientific way, the process of differentiation has begun. This is the process all planetary bodies go through at the beginning of their lives. Since the impact was very hot, its heat carried away most of the gases and liquids from the broken pieces of Earth. Only a relatively dry stone surface remained. So yeah, there is water and gases on the Moon, but in very small quantities. The gravity of our planet was strong enough to make all these hot stone fragments stay in its orbit, and they gradually began to stick together. The chemicals they contained were distributed in layers. Iron, which was heavier, sank deeper inside, and lighter elements formed the surface. In a short time, 100 years or less, the ring of steam, dust, and molten rock fused together. The largest clusters with the strongest gravity attracted more and more particles, gradually forming the Moon. It looked like a red-hot bubble ball. Sadly, the nucleus of this newborn Moon turned out to be very small. It lacked iron and other heavy elements to form into something substantial, like a planet. The oldest rocks of the Moon probably formed in the ocean of magma. And when the Moon gradually cooled down, it turned out to be a white, clean, and perfectly even ball. But it was still completely different from what we have now. To begin with, immediately after its birth, the satellite was located at a distance of only 13,500 miles away from Earth. This is 15 times closer than it is now, around 238,000 miles. It's scary to imagine how huge and bright the Moon looked in the sky at that moment. The view was probably both beautiful and terrifying. And, of course, such proximity caused incredibly huge waves on Earth. The planet experienced regular tsunamis. Also, at that time, the Moon was spinning very fast, and it wasn't turned to Earth with only one side. But, in general, Earth and the Moon had a positive impact on each other. For example, it was the Moon that made our day last 24 hours. Now, Earth's axis is mostly tilted 23.5 degrees from the plane of its orbit around the Sun. Without the Moon, Earth rotated rapidly, but thanks to the satellite, the planet's tilt stabilized, which led to a wide and pleasant variety of climates on Earth. To be fair, the gravity of our planet also helped the Moon. Thanks to it, the Moon began to rotate more and more slowly while gradually moving away from us. Over the years, its orbit has moved far away from our planet. At the same time, the Moon became tidally locked to Earth. This means that its rotation period coincides with its orbital period. Or, in other words, the Moon moves around itself as fast as it moves around the Earth. That's why the Moon always faces our planet with only one side. When the Moon moved away, tides on Earth became calmer. Now, water could flow to the most remote corners of our planet. It was then that life appeared on Earth. But back to the evolution of the Moon itself. What was happening on its surface after its formation? The next stages of the Moon's development were childhood and adolescence. And as is usually the case at this stage, this period was insane. No wonder. About 4 billion years ago, the solar system was going crazy. During the first 600 million years of the Moon's existence, large asteroids and comets constantly collided with it. Now, they were bothering not only our Earth, but also its satellite. These impacts were the most powerful in the history of the Moon. They left many large craters, which were later filled with dark rock. So, Earth wasn't enough for you, huh, space? Once, a dwarf planet crashed into the Moon. It was about the size of Ceres, the largest object in the asteroid belt between Mars and Jupiter. This explosion formed the SPA basin and also forever changed the appearance of the Moon. Can you see that dark spot on the far side of the Moon? Right there in this very south? This spot is called the South Pole Aitken Basin. Its diameter is about 1,600 miles. And yes, it was formed by the impact I've mentioned, about 4.3 billion years ago. This planet brought with it a bunch of complex and strange chemical compounds that scientists are now finding all over the far surface of the Moon. These compounds began to emit a lot of heat, melted part of the lunar mantle, and, oops, accidentally woke up volcanoes. The volcanoes began to erupt furiously. A huge amount of magma was distributed over the surface of the Moon. Many years later, it cooled down, leaving behind those famous dark splotches that we're so used to. They're called the lunar maria. There are much fewer craters there than on the lunar highlands. But for the last billion years, the Moon has been geologically inactive, except for occasional collisions with meteorites. In general, the appearance of the Moon changed forever as a result of these events, and, battered and tired, it entered adulthood. But even then, it couldn't get any peace. A bunch of meteorites decided to bother it again. Honestly, it wasn't that bad. There were many collisions, but all of them were quite small. They just left a bunch of craters and pits on the Moon, and maybe damaged its mantle a little. Some of the collisions deepened already existing large craters. The Moon's crust was getting thinner and thinner over the years because of all the chaos going on. And now we call this upper part of the lunar crust covered with craters the lunar highlands. all those white and bright areas of the moon, the highlands. But in the end, the universe finally calmed down, for now at least, and the moon began to look the way it does today. There are still many things we don't know about Earth's natural satellite. There are moments in its history that scientists still can't accurately explain, but they're continuing to study our beautiful satellite. The data about the moon is useful to people not only for its own sake. It gives us a more complete picture of both the history of our solar system and space as a whole. So, let's hope that one day we'll be able to find out everything there is to know about the moon.
Hey, ever wanted to taste a salad from space? Well, you might be able to one day. Scientists have taken soil from the moon and successfully grown plants in it. Back in the late 60s and early 70s, it was the first time in our history we set foot on a surface that wasn't Earth. During the several trips to the moon in the Apollo program, astronomers brought back some rocks and soil to study. The researchers named the lunar soil regolith and used the seeds of a particular plant called you can read it here, which is found in Asia, Europe, and parts of Africa. They crossed their fingers, not knowing what would happen. The only thing they did know was that the lunar soil was too poor in nutrients to sustain any plants. So they created a lunar soil stimulant made from volcanic ash to replace the real lunar soil and went to work. Since they needed two separate experiments, they planted the seeds in Earth soil. It was a controlled experiment. They also planted some seeds in the lunar soil as the variable. They were very careful and used a single gram of lunar soil for the experiment. To their surprise, it only took 2 days to see little green leaves and 6 days for them to be properly visible. But sadly, after day 6, the lunar soil plants stopped growing. The soil wasn't enough to provide the needed nutrients for the plant to thrive. The seeds in the soil from Earth, however, grew lavishly. But not all was lost. Even though the lunar plants didn't continue growing, they survived and were harvested 20 days later. Sadly, they still didn't produce a yummy space salad. The scientists then studied the biological form of the plants and found out that the lunar plants were developing under a lot of stress, as if they were growing in a harsh environment, compared to their counterparts in the regular Earth soil. Either way, the study was a huge success. It was the first step in growing food in the soil that wasn't from Earth. NASA planned on a new moon landing in 2024, but due to some complications, it was pushed back to 2026. This will be the first time a person sets foot on the moon since Apollo 17 in 1972. The next moon landing mission will allow us to collect more lunar soil samples to experiment with other crops and see which ones can live longer. Lunar soil in its natural state is far from the quality soil we have on Earth, but we might find a way to reduce the stress plants growing in it have to endure. Perhaps it'll let plants develop in similar conditions they would have in a proper natural setting. There might be other materials on the moon that can help plants grow healthy. The mission will be under the Artemis program. Elon Musk's SpaceX has been commissioned to build the lunar landing vehicle. At first, they will launch a test flight lasting about 3 weeks and then send astronauts to land at the moon's south pole. Because that section is untouched by sunlight, scientists believe there might be water ice craters there that can be used to make rocket fuel. It would lower the cost of future moon expeditions, since fuel wouldn't have to be imported from Earth. Besides potentially growing plants in lunar soil, using water ice from the craters as fuel would be another way of making the moon self-sufficient for space exploration. Now, Mars would be one of the most difficult places to migrate to when you consider how Earth sustains life. But scientists believe that with the right engineering and living conditions, Mars can potentially become our new home. The red planet has a very similar force of gravity to that on Earth, which means that constructing buildings with proper infrastructure wouldn't be much of a problem. Our biological clocks wouldn't be too affected either, since a day on Mars is roughly 40 minutes longer than on Earth. Elon Musk plans on sending out robots to test the conditions on Mars before humans set foot there. These robots will be humanoids, mimicking the way people walk and move. They must be built in a special way to test how the conditions on Mars would affect us physiologically. These robots can also start constructing buildings for people to live and work in. We would have to be tremendously advanced in our agricultural innovations to grow crops in hostile environments. Despite being called the Red Planet, Mars is actually chilly, so we'd have to build giant dome-like structures to house a human population. They'd need to be self-sufficient enough not to have to rely on Earth's natural resources. These domes would protect us from harsh sandstorms and sub-temperatures. Now, a mission to Mars might not happen in our lifetime, but at the moment, we can take the first steps. Since we've found out that we can use lunar soil to grow something, the next step is to understand more about the process. We won't be living on the moon anytime soon, so we can use the studies of lunar soil to help us solve some problems on Earth. Countries like India are adapting smart farming that uses robots to speed up the process. Some robots are designed for seeding, harvesting, watering, and other tasks. Robotic manufacturers are in high demand now. They produce unique machines like self-automated tractors and aerial vehicles that can hover over fields and water crops. This form of farming will increase productivity and reduce overall costs. It will also help save water by studying the exact volume crops need. A cool, innovative way of farming is vertical farming, which can be done in heavily populated cities. You can practically use any abandoned warehouse or building to do it. It recycles water used at the top of a vertical farm. It drips to lower levels and is then used again. The farmers stack plants in vertical beds for the water to drip easily. They also use both natural and artificial light. These farms are usually soil-free. Instead, plant roots remain in a nutrient-rich solution that is constantly monitored. This method is cost-efficient and supplies plants with the exact amount of nutrients they need. Other vertical farms use ponds with fish living at the bottom. These fish produce waste that is very rich in nutrients. Plants can use it as food. Vertical farms are growing more popular and may soon replace traditional farming. Vertical farming will allow farmers to grow almost 10 times the amount of produce than a plain field, all because they utilize the space above and below. You don't have to worry about little critters on the ground stealing your crops. You should only worry about flying ones. Indoor farming is becoming very popular. Crops growing outdoors always face natural hazards that can damage them. But with indoor farming, we won't have to rely on seasons to grow certain crops. Indoor farms can replicate the conditions of all climates, and we can have any fruit or veggie at any season. There's also genome altering to make every crop the best of the best. It will eliminate any bad seeds, literally. We won't have to waste tons of crops that aren't suitable for consumption. They can have extra nutrients and be healthier. All of these methods are just the first few steps before we begin with space agriculture on planets with hostile environments. Growing plants in space isn't something new. The International Space Station has an array of specialized gardens for growing veggies. Scientists are studying growing crops and plants in zero gravity, which can provide fresh food for astronauts. They use LED lights above plants to accelerate their growth and install proper watering mechanisms. This might be useful for a handful of astronauts at the International Space Station. But what if we were traveling across the galaxy to populate new planets? Well, we'd have to consider a large space dedicated to indoor farming. On the other hand, technology is likely to improve so much by then that we won't even need veggies and fruits in our daily diet. There might be other yummy alternative stuff to munch on. But hey, I'd rather have that space salad, please. Do you have any croutons? That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these